How far do you think a modern probe can go into space in 44 years? What will it see outside the earthly environs, and what dangers will it meet on the way? We know the answer to the first question for sure. At this stage, an unmanned vehicle created at the end of the last century, in less than half a century, can fly about 11 billion miles, an unthinkable distance by earthly standards. This was clearly proved by Voyager 2, which for many years plowed the pitch darkness of the universe, and you won't believe how many mysteries the little space explorer revealed during its journey. Equipped with many research instruments, Voyager 2 gave astronomers a detailed description of its heroic route through the solar system on its way to distant stars. Where do we start? Perhaps from the data obtained by the probe within the solar system. But what about high-tech telescopes, you object? Haven't they been observing neighboring planets for a long time, regularly transmitting useful information about the objects? Yes, but their activities can't be compared with the work of a probe located in close proximity to a cosmic body. In the second case, the incoming information is much more informative. So, where did the Voyager 2 mission start from? It began with huge Jupiter, which, if desired, is capable of absorbing all the planets of the solar system. Of course, we already knew that our system consists of stony terrestrial objects and gas giants, and we're also aware of the ice rings of Saturn and global Jupiter hurricanes. But these are only scraps of information, the gaps in which Voyager 2, as well as its inquisitive twin brother, undertook to fill. Jupiter. Voyager 2 began sending images of Jupiter to Earth on April 24, 1979. The first images sent were of the gas giant's turbulent atmosphere. Astronomers put together a short film from a series of photographs and learned more about the principles of atmospheric circulation. Unlike Voyager 1, the second probe was very close to Jupiter's moons, Io and Europa, capturing the period of their approach. The result is amazing images of Jupiter's vast system, including crisp images of its moons Callisto, Ganymede, Europa, Io, and Amalthea. At the closest point to Jupiter, Voyager 2 was on July 9, 1979, at a distance of 4,785 miles. From this location, the probe transmitted updated data regarding the planet's clouds. 4 satellites in a ring system were rediscovered, and 17,000 new images were obtained, combined from the cameras of the 2 Voyagers. At least 80% of the surface of Ganymede and Callisto, as well as Saturn, have been mapped by astronomers. As a result, Voyager 2 to some extent repeated the photographic mission of its predecessor, and then surpassed it. Saturn. The meeting of the probe with the 6th planet of the solar system took place on August 22, 1981, 2 years after the device left Jupiter and sent the first images of the Saturnian satellite Iapetus to Earth. When Voyager 2 flew past Saturn, it was confirmed that its rings are about 980 feet thick. But this is a very average value, since in some places this parameter reaches only 10 to 100 meters. During its journey near the planet, the probe passed through the rings of Saturn at a speed of 8 miles per hour. It happened very quickly, taking just seconds. During a risky maneuver, a myriad of dust particles simultaneously pierced the metal body of the spacecraft, leaving plasma trails behind. Voyager 2 also captured Saturn's moons Hyperion, Enceladus, Tethys, Phoebe, and the newly discovered Callisto and Calypso. Uranus. It would seem that the 2 main tasks had been completed. It's time to retire, but scientists prepared a different fate for the probe. The developers decided to send the veteran ship to Uranus. The meeting with this planet, among other things, opened up the possibility of flying to Neptune. But before that, Voyager 2 carefully studied the ghostly and remote Uranus for 5.5 hours. The probe was a pioneering human-made craft that flew past this planet. Extended observations of Uranus began on November 4, 1985. The first signals of the probe reached the Earth in about 2.5 hours. What difficulties did Voyager 2 encounter in studying this cosmic body? The most tangible problem is the lack of light. The icy planet receives 400 times less of it than the Earth. The closest approach to Uranus occurred on January 24, 1986, at a distance of approximately 50,640 miles. What iconic discoveries in this location did Voyager 2 make? The probe discovered 10 new satellites that were named after the heroes of Shakespeare's tragedies: Buck, Portia, Juliet, Rosalind, Belinda, Desdemona, Cordelia, Ophelia, and Bianca, found 2 new rings in addition to 9 already known, and recorded a magnetic field tilted 55 degrees and somewhat off-center. Voyager 2 also sent back impressive photos of Uranus' large moons. After rendezvousing with the planet on February 14, 1986, the spacecraft made a single midway gravity maneuver, the largest and most significant ever performed. Voyager 2 needed to do this to plot a route to Neptune. The probe flew to Neptune on August 25, 1989. To do this, Voyager 2 covered about 9,980 miles, flying over the clouds of the giant planet, which turned out to be closest during the 4 orbits made when approaching them. Meanwhile, the spacecraft didn't stop its painstaking work. For example, it discovered 6 new satellites and 4 rings. Neptune itself proved to be a real box of surprises. In particular, it turned out that it's not at all calm on its surface. Hellish winds are constantly blowing there at speeds of about 68 miles or 110 kilometers per hour. And this is the smallest indicator, because the speed of atmospheric flows of some stable storms on Neptune is the highest in the solar system, reaching up to 2,400 kilometers per hour. Did the probe manage to learn anything about Neptune's atmosphere? Scanners showed that the most common element is hydrogen, although methane was also present in the atmosphere, giving Neptune a nice blue tint. 3 huge structures, presumably hurricanes, are clearly visible in the image: the Great and Small Dark Spots and Scooter. Voyager 2 also captured 2/3 of Neptune's largest moon, Triton, the coldest known body in the solar system, and a cryovolcano that pours nitrogen onto the planet's surface. Breathtaking images of Neptune's southern hemisphere captured a strange terrain that resembles a bearded melon. Voyager 2's mission to this location ended with a triumphant flyby around Neptune. It's worth noting that after studying the distant planet, the probe functioned for many more years. For example, in 2011, at a command from the center, it switched to alternative engines responsible for the navigation system. And in 2019, NASA announced that it had received data from the interstellar medium transmitted by the device. Where did Voyager 2 go next after visiting Neptune? For some time, the probe followed a course below the plane of the ecliptic and left the solar system at the turn of 35 million miles from the place of departure. After the encounter with Neptune, many Voyager 2 instruments were switched to a low-power mode to save energy. It's noteworthy that 12 years after the launch, in November 1989, NASA officially renamed the project to the more snobbish Voyager Interstellar Mission spacecraft. Instruments of secondary importance were permanently deactivated. Only 7 research gadgets continue to function on board the probe. What fate awaited the second Voyager next? By November 5, 2017, the spacecraft was about 116 astronomical units, or about 11 billion miles, from Earth, moving at 9.6 miles relative to the Sun in the direction of the constellation Telescope. If Voyager 2 maintains current speed parameters, it'll take approximately 19,390 years to cover a distance of only 1 light-year. Do you want to know what significant event happened on July 8, 2019? On this day, on a command from the Voyager 2 Center, it successfully launched the maneuver trajectory correction instruments that are used to control the spacecraft for the foreseeable future. Further, on October 28, 2020, NASA re-established contact with Voyager 2, more than 11.6 billion miles away from Earth. Now, the probe is outside the influence of the Sun in the interstellar medium. By the way, the original Voyager mission was designed to implement a program called the Grand Tour, which involves a large trip to the planets of the solar system. An ambitious plan in the late 1970s was for a sophisticated space exploration craft to explore the 5 outer planets. But scientists were forced to partially freeze the project in January 1972, primarily due to unjustified costs projected at $1 billion. Instead, it was proposed to launch just 2 spacecraft to Jupiter and Saturn in 1977. Both probes were designed specifically to study the 2 gas giants, and they were far more suitable than their predecessors, Pioneers 10 and 11, launched in 1974. The mission planners suggested that if the first Voyager succeeded, they would redirect the second one to Uranus and Neptune. This could be done using gravitational maneuvers, as happened later. Each of the 2 spacecraft was equipped with a slow-scan color television camera to take pictures of cosmic bodies and their satellites. The vehicles also had an extensive set of instruments for recording magnetic, atmospheric, satellite, and other data about the planets and their satellites. Both spacecraft designs were based on the older Mariner models. Until March 7, 1977, they were known as Mariner 11 and Mariner 12. Then the head of NASA, James Fletcher, announced that they would be renamed Voyagers. But everyone's wondering what Voyager 2 is doing right now. In the dark depths of space, billions of miles from home, NASA's Voyager 2 spacecraft has become an important link in astronomical research, becoming the second probe ever to dive into interstellar space. But of course, such a serious mission didn't go smoothly. As of November 2018, NASA, as usual, kept in touch with the probe, but one day the agency staff were unable to contact the device, which was quite a surprise. This was preceded by an unprecedented event that occurred on January 28, 2020. What happened? Was the spaceship attacked by aliens, or was it swallowed up by a black hole? No, just the probe suddenly stopped moving. Voyager 2 stopped just before making its planned maneuver. The craft had to turn 360 degrees to calibrate one of the onboard instruments, but instead it didn't budge. As a result, both Voyager systems worked non-stop, consuming huge amounts of energy. So what was the problem? The spacecraft used up the available power source too quickly, and this led to the launch of the protection system. When rebooted, the software automatically turned off Voyager 2's scientific instruments to save power. After all, it has a rather limited supply of resources. The issue needed to be urgently addressed as Voyager 2 continued to move away from Earth. Thus, in order to avoid such failures and significantly improve communication, an antenna modification plan was proposed as a solution to the situation. During the implementation of the project, radio communication with Voyager 2 was completely turned off, and for a whole year. It was a risky undertaking, but necessary, so the engineers went all in. Fortunately, the year of silence passed relatively calmly for the probe, so the project was completed successfully and rather quickly. Contact with Voyager 2 resumed on November 2, 2020, after a series of instructions were transmitted to the vehicle using a special communication channel. As a result, on February 12, 2021, communication with the probe was finally restored. Now the Voyager 2 mission is active and fruitful again. The device continues its interstellar flight, simultaneously studying the environment and sending data to Earth. Although the probe's camera isn't strong enough to produce high-quality images, Voyager 2 is still important to mankind in terms of space exploration. This is the second interstellar object created on Earth, and the only one with which we keep such frequent contact. That is, at the moment, Voyager 2 is the last of the Mohicans, one might say, a representative of an endangered species. Certainly, there will come a moment when its power source runs out and the mission will come to an end, leaving the probe forever wandering in the icy embrace of infinity. Subscribe to the Hubble channel, leave likes, and don't forget to share this video with your friends. Let them learn more about the secrets hidden behind the glare of galaxies and the veil of nebulae. If you agree with the great scientist, be sure to like and subscribe. The more likes we have, the more interesting content the Hubble channel produces, as it has already happened by tradition. If under this video we manage to collect 1,000 thumbs up, a new, very exciting video will be released immediately. The main thing to remember is, educational videos promote the development of intelligence, and don't you forget it.